So we've talked about the tonality of different compressors. Now we're going to talk about the characteristics. Starting early off in compressor history, most compressor designs were VGAs, variable gain amplifiers, and the fact is that while they did what the job required, they were not particularly good. They specced out very badly and had lots of audible artifacts. So the modern compression that we're used to hearing in studios really starts in the 1950s, and that starts with one of the coolest compressors ever designed, the Very design, and the most famous is the Fairchild 670. The Fairchild 670 is all tubes, everything. The cool thing about the Very is that rather than relying on some kind of an integrated circuit chip to manage the gain reduction, it actually relies on tubes themselves. The level of the incoming signal changes the tube bias, which then in turn changes the amplification stage, and so the way the tubes are naturally reacting to the incoming level dictates the way the output volume is regulated. Okay, what the heck did all that mean? Well, it means that the natural curve in which tubes reach their limit of how much voltage they can handle has a very cool knee to it. It's very circular. The ratio is effectively becoming greater as more voltage comes in. So it's asymptotically approaching this hard limit, more or less. Another thing to note about this design is that the speed of the Very is fairly slow in the world of compressors. The faster Very designs, Manley Very and Fairchild, are about 25 milliseconds on the attack time, which is fairly slow in the world of electronics. And the release time is also generally not particularly fast, usually about a fifth of a second. Okay, but these are really musical compressors because of that variable ratio. However, for things that want a consistent ratio, another very musical design came about in the early 60s, and that's the optical compressor. The optical compressor is based on a photosensitive panel that's receiving light from a voltage-charged LED, and that's connected to a resistor. And so the amount of light basically dictates the amount of gain reduction. Okay, so there's some really cool natural things that happen as a result of this, and one of them is that the time constant changes. So kind of like how there's that variable ratio in the Very this has a variable time constant, and the end result looks like this. You have a slower attack time as gain reduction is first applied, and then the attack time starts speeding up as it approaches maximum gain reduction. Similarly, as the gain restoration starts to occur, you have a faster release, which then starts slowing down as the LED starts retaining some of its light. It lets go of the light a little bit slower. This is a really cool effect. It's a very musical way of doing things on extremely dynamic material because it's almost like having a volume crossfade happening from your compression stage, if that makes sense. And so the subtler effects are subtler. The more the compression is needed, that kicks in a little bit faster. As far as the actual timing goes, opticals can be pretty fast. I think the faster ones are about maybe half a millisecond, which is fast enough to get most jobs done. They tend to release very slowly, though, simply because the LED just doesn't let go of all of its light. That's not really what they do. So I think about 50 milliseconds is where the average optical compressor is functioning. Okay, so let's say that you want something that's faster. Well, in comes the 1176. What is that? It's a FET design. That means field effect transistor. It's going back to an older style of compressor, but it's been modernized by the good people at Universal Audio and URI to function in a slightly better way. I mean, now there are tons of artifacts. No one will argue that an 1176 is a very colored compressor, but it's a very cool color, so we like it. It's fast. That's one of the advantages to the FET design. It is super fast. How fast? 20 microseconds. 20 microseconds is actually faster than your DAW will sample sound when you're recording at 44.1. It's about this. It's 20 microseconds will allow light to travel 5 miles. That's how fast we're talking here. So it's almost instantaneous. Obviously, when you're cooking with that kind of speed, there are definitely going to be some results from the drive of the electronics. But sometimes you want a hard knee and a very fast reaction, so it's perfect for that. Okay, what else do we have? Well, now we have this other set of compressors out there under the umbrella of VCAs. VCAs, generally referred to integrated circuit compressors, there are so many different ways that can be set up with different resistors or Zener diodes or whatever else. The bottom line is the variables get pretty out there, but in general, you're looking at things which can be fast and clean and precise. And that's usually what people are going for. Now, the SSL compressor has a variable knee setting built into it. The Neve 33609, it does not. So it depends on the individual compressor completely. And that brings us to the conclusion of this, which is that I'm trying to make a point. The individual compressor is going to vary a great deal across the board. In today's modern day, even entry-level engineers have access to a lot of things. Plugins are so affordable these days that it's not uncommon to see studios, whether it's your average bedroom studio all the way up to a professional high-end studio, with just an endless list of plugins, and sometimes, huge racks of hardware as well. With all of these options, it becomes difficult to actually master and truly embrace the individuality of each piece of equipment. So I would challenge you to do this. Next time you're doing a mix, pick 2 compressors, maybe even at random, and force yourself to do the mix using only those 2 compressors and nothing else. Why? Because if you really get to know these compressors, you start unlocking doors to things that you can do with them and unique aspects of those compressors that you can use in situations. So rather than just relying on the crutch of having all sorts of different things at your disposals, oh, this is the vocal compressor, oh, this is the bass guitar compressor, you now have tools at your disposal that other engineers wouldn't necessarily have, just because you know that you can create these effects with this compressor, and maybe it wasn't designed for this source, but you could use it in this way, etc., etc. All right, guys. Hope that was a valuable lesson.